it looks like that. Let's create it real quick, just point something out. Rational function. Now, what I was using yesterday, where they asked you where is the horizontal asymptote, that little guideline for the graph, where is that located? Is it up at 3? Is it down on the x-axis? Is it somewhere, that horizontal line? You gotta find where it is. And I was using from calculus that, I think, 1 over x. Wasn't it? Was I trying to use that 1 over x, and we went through that routine to find out where it is. Now, here's a shortcut. You're going to appreciate the shortcut. I went through that 1 over x, which you'll see that in calculus. You guys can mess up, you'll see that again with that 1 over x. I actually showed you that. The shortcut is, now here's the first case. If the degree, highest exponent, if they match up to the same number in the numerator and the denominator, the horizontal asymptote is always located at location, this number, this coefficient, over this coefficient. So quickly, my horizontal asymptote is guaranteed to be, in this case, up at 2. I love that case, but that's when those degrees match up. They gotta match up exactly. So we're having a horizontal asymptote at 2 in this case. We change it. If, what we're saying here, if it were even that, as long as they match up, they're the same number. And they ask you, where's the horizontal asymptote? The easiest case in the world, without going through the 1 over x. This coefficient over this coefficient. Now I have a coefficient of 1 now that I don't want to throw you. If that coefficient were a 3, then of course your horizontal asymptote would be up at 2/3. That coefficient on the numerator over the coefficient on the denominator. That's the easiest case. Now, professors, suppose they're not the same. It's not a 3 to 3 or a 4 to 4. What it looks like this. R of x is equal to, let me keep my, I think I originally had a 3 here. Let me keep that numerator the same, just for discussion purposes. And then down here this time, let's say you have, yes, that. And you check out the degrees. You say, professor, the degree here, the highest exponent's 3 here in the numerator. Denominator, professor, is not the same. So I can't use this easy case. But I can still do something with it. Is this one on top in the numerator exactly 1 larger than the degree on the bottom? Now this is going to be into a lesson on Monday. I'm going to end up with another type of an asymptote known as an oblique, which I have not discussed yet. It's 1 in the numerator, it's exactly 1 larger. You're going to end up with an oblique asymptote. Now, you say, Professor, what are you talking about for an oblique asymptote? We did horizontal. I know what a horizontal line is. You know what a horizontal. That's a horizontal, could act as a horizontal asymptote. Vertical, I did yesterday. That's a vertical. But what's an oblique? You said you're going to hold off since we have a test until Monday to show me, but it happens in this case. Yeah, that's a diagonal. It's going to be acting as your asymptote. So we've got a vertical asymptote. We know what a vertical line looks like. Horizontal from yesterday, we know what a horizontal line looks like. But weird, strange, if this is exactly 1 larger than the bottom degree, you're going to end up with an oblique that looks like that. And that's coming up on Monday. Think of another case here before I leave it. Let's change it. The R of x is equal to, let me put this x squared plus 6 in the numerator. And down here, this. Watch carefully, listen carefully, little shortcuts on how to find the horizontal or how to find that asymptote, especially horizontals. Guys, when I examine the degrees, no, they are not the same, which is the best case in the world. And And the one on top is not exactly one larger than the one on the bottom there, like I did for an oblique. That would give me an oblique. But they're not the same. Is this one on top smaller than the one on the bottom? If it is, you automatically will have the x-axis, which is y is equal to 0, acting as your horizontal asymptote. Just a few little shortcuts. June, Mr. Park, you guys, I don't know if in all your math background whether you had to rely upon those little tricks there to find the horizontal asymptote, or you went through the 1 over x business, but we could. Okay? So guys, I'll tell you more about this on Monday. I thought I'd better point it out now. Okay, I love this case. You'll love this case. Oh my goodness, Professor, next Friday, please give me one where they match up. Exactly. Now all I have to look at is this coefficient over this coefficient. And I'll go directly to that number and draw my horizontal line. Saves a lot of work rather than doing 1 over x. Okay? I thought I'd point that out before I jump into what I got to do today before that test takes place. And before I jump into to this, let me do a little survey. How many students are taking advantage of what June sends out and what Mr. Park sends out? They're taking notes for you every day. I mean, beautiful notes. And in fact, adding to what I said in class, or adding to it. Are you looking at those? That's a big, big, big benefit. I'm so glad I have my 2 TAs. Okay, guys, here's what I got to do. I'm moving into chapter 4. I have some handouts. As we go from one chapter to another chapter, the topics change, but also you may see a relationship from a previous chapter as I go into a future chapter. But I'm moving into chapter 4, and I'm going to finish up this chapter 3, rational functions, on Monday. Unless you guys want to come in tomorrow. You guys want to come in tomorrow? Oh, look at that. Oh, let's see, one can go up. Oh. I guess I'm going to wait till Monday for the rational functions to be completed. Now, here we go. Part 1. Chapter 4. Starts us out with, I got a handout here shortly. This, I'm going to set you up first. Let's see if I have it here. How beautiful. Why not? Save you from copying so much. Now, by the way, do you guys appreciate that I did take the time to put what section I'm doing this with? And what section, and therefore you can sort of guide yourself?